So are there any differences in how you should study for three different subjects? Yes, very good question. The question by Soham is, are there any differences in how you should study physics, maths, and chemistry? So the question is, what is the difference between physics, maths, and chemistry, and what steps should I take while doing the self study? Is there any difference, or should I follow the same process or same actions for all three? But yes, let me tell you, there is a difference. Okay, there is a difference. Now there are some common points also. So what we look at both the common points, and we will look at the differences also. Okay, so we will look at the common points and we look at the differences also. So the first common point is theory in detail. So that you have to do for all three. You have to study theory in detail. You have to pay attention. You have to pay attention on each and every word. The activity that we did last time, paying attention on each and every word, understanding each and every word in as much detail as possible. If we don't know the meaning of the word which we are reading, we will not move ahead unless we understand the meaning of that word in entirety, in complete, okay, or in simple language. So pay attention on each and every word. This is a common for all three. Each and every word, each and every line, each and every paragraph. This is the common thing. The second is practice derivations. Practice derivations, again, this is also common for all three: physics, maths, chemistry derivations. Whatever comes your way, you need to learn how to derive the formula. Just mugging up the formula will not help you. You should know how to derive the formula. Okay, so these are the two theory elements. Then solved examples. You have to do solved examples for all of them. Okay, but here is the difference. So the difference is that in physics and chemistry, I'll recommend around 50 solved examples per chapter. Okay, around 50 solved examples per chapter. But for maths, I'll recommend 100 to 150 solved examples. Okay, because maths is learned through examples. Maths does not have much concepts. The concepts are very limited in maths, but the variety of questions that got formed on the maths is very high. But the concepts are limited. In physics and chemistry, still we have concepts and we can master those concepts, understand, visualize those concepts. But in maths, it's very limited, very, very limited. We are not able to basically identify what variety of questions get formed on those concepts. So we need more and more solved examples in maths. Okay, and then when it comes to unsolved questions also, I'll recommend for physics, chemistry around 200, 250 is fine. Okay, but for maths, I'll recommend around 300 to 350, because again, the variety of questions that get formed on the concepts of mathematics is too high. Now, what is the difference in the theory element? In theory element, again, physics is more of a, first part of physics is complete visualization. If your visualization is very good, and if you follow the systematic approach of creating the diagram, copying the data points, and then applying the concepts and then doing the calculation, you will not make mistake in physics if your visualization and systematic approach is sorted. In chemistry, what happens? We struggle on visualization. So what we need to do, we need some animations, we need some atomic structures, some visualization technique in a deeper way, because everything in chemistry happens at the atomic or the molecular level. Okay, but in physics, a lot of things happen at the macro level. That means body is moving, train is traveling, flight is taking off or landing. Okay, projectile motion, all these, the first part of physics is complete visualization, very simple, that we see in day-to-day life. But chemistry, everything happens at the atomic level, so we struggle on visualization. That's why we need some very powerful animations for all the topics that we study, and along with the systematic approach that is there for all the three, valid for all the three. But for maths is complete observation. Maths does not have much visualization, it is complete observation. Now, what is the meaning of observation? Let's say you know about x1, x2. Okay, you know x1, x2 in maths, but how to use these x1, x2 in million different ways, that is called observation. Okay, so one way to explain observation is that, let's say you are watching a painting and I'm watching a painting. So in that painting there's a horse and there's a garden behind him. Okay, but when you will observe, you will just see a horse and you will just see a garden. And let's say if my observation is very deep, then what I could see is that I could see the face of horse, I could explain the horse in much better way, I could explain the garden in much better way, I could see much more things than what you are able to see. So this is what we call observation, and this observation is very important in maths. So let me give you an example. Let's say quadratic equation, ax square plus bx plus c is equal to 0. Now there are infinite ways that we create this quadratic equation. Okay, lot of variety we see the type of determinant, we see the type of roots, the sum of roots, product of roots. Okay, all these formula we see, then we see the graphs, we see the inequalities. Okay, lot of variety gets formed just by looking at this. So all these are coming up through very powerful observation. Okay, variety of graphs, then inequalities, all these things. If you don't know these things, but if you know this very well and if your observation is very good, you can go and derive all these things yourself. Just you have the awareness, but you can go and derive all these things yourself, just you have the basic knowledge. Okay, so even in this, lot of variety of questions will get formed, lot of cases for A, lot of cases for B, lot of cases for C. The roots are complex, the roots are real, and so on. Like this, different varieties and multiple varieties is required. That's why solved examples, more and more solved examples is required, around 100 to 150 on each chapter of maths. So these are some of the differences. Physics you can see, chemistry it's hard to see, but you need then animations, and maths is total observation and feel of graphs. So feel of graphs, the feel of numbers, okay, the feel of functions, the feel of numbers, the feel of functions, all these things are part of the maths. So you need a very strong observation. Observation also helps you do well in physics and chemistry. And when we see students coming to IIT or different good colleges, we see that they have very powerful observation skill. That means two students are seeing the same thing, but one is going much deeper into it and the other is not going much deeper into it. But the ones who go deeper is the kind of students we see in IITs. Clear?